Okay, this is our second day of 8.2.3, more complex numbers and equations, and we're going to look a little bit more today into the equation part, but we're also going to go back and look at the graphs. So in 8-101, they're asking us to think again about the possibilities. Here's what I mean. When I have a parabola comes from an x squared. So I have three different possibilities of how that parabola can be on the graph. Okay, I can either have the graph cross twice, cross not at all, and we talked about both of those yesterday. I can also have the vertex sitting right on the x-axis, which means it touches just once. Okay, but remember, if this is a second degree polynomial, we know that it has to have two roots. Okay, when we can see the roots, we can see where they cross the x-axis, that means they're real. Two real roots. When we can clearly see that they don't cross the x-axis, that means that we have two complex or imaginary roots. Okay, so what about this one? This one's a little bit different. It does definitely have two roots. They're definitely real because you can see it touches the x-axis, but it's only one place that it touches. So we say that it has one distinct real root, okay, but we call it a double root because it bounces. Okay, so if I'm asking you which of these graphs have real roots, the first one and the second have real. This one does not have any real roots, it only has complex roots. Okay, which ones have complex roots? Only the third graph. They all three have three roots, technically speaking. This one is just a one root, but it's a double root. Let's also talk about, and we talked a little bit about this yesterday, a cubic. So we know that a cubic is going to look like either an up, down, up, or down, up, down. So either like this or like that. That's what a cubic looks like. Okay, and again, there are three possibilities here. Of course, it can cross the x-axis 3 times. We looked yesterday. It could potentially only cross the axis 1 time. Okay, but the other option is it can cross and then it could bounce. Okay, so same as what's above, this one has 3 real roots. Okay, this one has 1 real root. And remember, the roots always have to add up to 3 because this is x cubed, right? We said these are all cubics. Okay, so 1 real root, the other 2 are complex or imaginary. Okay, this one has 2 distinct real roots. Okay, and this one right here counts as a double root because it bounces. Okay, so because it's a double, it counts for 2, and then this one is 3. That's where we're getting our 3 roots. And that's just a reminder what it looks like graphically. In question 8-103, it's asking us to consider this equation. And of course, this is a cubic, so it's going to look like one of these 3 things. It's either going to cross the x-axis 3 times, it's going to cross and bounce, or it's going to cross and then make another, I don't know, swoop or S or a curve without touching the x-axis again. And we're going to learn more tomorrow and the following day on how we get to this point. But for part B, it asks us to verify that this equation is also equal to x minus 2 times x squared minus x plus 1. And again, you don't know how to get this yet. We're going to show you how to do that tomorrow. They just want me to verify that those 2 things are actually equal. And remember, if I have 2 items, x and a minus 2, times 3 items, x squared, negative x plus 1, I'm just making a 2 by 3 generic rectangle. X times x squared is x cubed. X times negative x is negative x squared. X times 1 is x. Negative 2 times x squared is negative 2x squared. negative 2 times negative x, 2x, and negative 2 times 1 is negative 2. So if I add up everything on the inside, x cubed, negative 2 minus 1 is a negative 3x squared. Okay, those are just like terms I'm combining. On the diagonal, you have like terms. 2x and x is 3x, and then you have a negative 2 with no like terms. That's what we started with. All they wanted us to do was verify. And you're going to see tomorrow why it's important for you to remember to do this. Tomorrow we're going to be undoing this and going backwards, but we'll get there tomorrow. Next, part C says find all the roots. So what they did, we didn't do it. They factored this equation, and we're going to learn how to do that tomorrow. And they want us to find what the roots are. And so what we can do is we can use their factored equation, and we can use the zero product property, okay? As long as we have factors that either have a degree of 1 or a degree of 2, we know how to solve these. So remember, for the zero product property, x minus 2 equals 0, that part's easy, okay? That tells me this graph crosses the x-axis at positive 2, okay? So still, it could be any of these three things. Let's see what happens here. When I do x squared minus x plus 1 equals 0, I cannot factor this. And so when I cannot factor it, I have to use the quadratic formula. Okay, so the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, these numbers make it pretty easy. This is going to be 1 minus 4. Okay, and as we remember, when there's a negative inside the square root, it becomes an imaginary number. Okay, and I'm going to split that up. That 2 gets split into both parts. So, are those parts real or imaginary? Well, they have the I in it, so of course it's imaginary. So what that tells me is that this graph is something like this one. Okay. Of course, it doesn't look exactly like that because we know it crosses at positive 2, but the fact that there's an I tells me it zigzags without touching the x-axis again. Okay? Last question for today is a short question. Question 103 wants us to look at f of x equals x squared plus 4. Okay, we're done with these. That's, of course, a quadratic. So it's going to look like one of these three things. It's either going to have 2 real, 1 distinct with a double root, or 2 complex roots. Okay? And in this question, it wants us to think of the sketch of the graph first. So we know that this is a parabola that shifted up 4 units. And of course, it has a positive orientation, so we're opening upwards. So we can tell just by sketching the graph that this doesn't have any real roots, but it is a parabola. So it's going to have 2 complex roots just by sketching the graph. I didn't even need my calculator for that. Okay? And you don't either. Then we want to actually find what the roots are. So we know that they're complex. Okay? To find roots, we just put a 0 in instead of the y, or the f of x. Okay? If I'm going to solve for x, you certainly could do the quadratic formula, but because there's only an x squared and not an x value, it's actually easy to undo. So I'm going to subtract 4 on both sides. I'm going to take the square root of both sides, and here I do have to keep in mind, when I take the square root of something squared, I have to use plus or minus. Okay? What's the square root of negative 4? Well, because there's a negative, it's going to be I. The square root of 4 is 2. So my solutions are plus or minus 2i. Okay, and obviously because of the I, they are complex roots.